children with neurodevelopment disorder, with particular emphasis on autism. As an AI and HCI researcher, Ashwini ma'am focuses on characterizing and qualifying human behavior to enhance machine intelligence, aiming to improve machine interpretations of human actions, emotions, and intentions for more responsive and effective applications. Our research aims to develop and design solutions that are not only cost effective but also contextually appropriate for resource constrained, reflecting a deep understanding of the diverse needs and challenges in things. Our work, our work has been published in reputed venues like CHI, Nature Scientific Reports, ICA, SSP, Roman, and SAR. So thank you, ma'am. Thank you for coming and accepting our invitation. So now I hand over the session to Dr. Ashwani, ma'am.
Yeah, thank you for the introduction and thank you for having me here today. Uh, just give me a moment to share my screen. Hope I am audible to all.
Yes, ma'am. Yes.
Can you just confirm if my screen is visible?
Yes, ma'am. Yes, ma'am. Visible, ma'am.
Yeah,
Visible.
thank you so much. Hello all. Hope you are having a great day today. A lot of sessions. So I will take it in a very lightweight mode. I as given in the introduction, I am an assistant professor in School of Artificial Intelligence and Data Engineering in IIT Roopar, and my research has been focused on modeling the behaviors using AI and machine learning techniques, which will help in diagnostics as well as interventions of neurodevelopmental disorders. And my focus previously was majorly in autism spectrum disorder, and in general, I my interests are in behavioral modeling, which will help us in understanding human behaviors and using them for better diagnostic as well as interventions. So I will first briefly go through what my research interests are, what is the area, to give you a background of the later on research, and then briefly introduce what is autism, then moving on to the motivation behind why this particular problem and what are the problems that I have explored in my research, and how it eventually helped in coming up with some solutions. Okay, so today I'll be presenting my research on empowering autism diagnosis and artificial intelligence assisted assessment in the Indian context. And this work has been done in collaboration with the Indraprastha Institute of Information Technology, Delhi. And I was particularly part of Human Machine Interaction Lab during the course of this work. And I would like to acknowledge each and every member of them, and thank you, IIT Roper, for this opportunity. So, briefly coming on to what is autism spectrum disorder, it is a neurodevelopmental condition characterized by challenges in social communication, restricted interest, and repetitive behaviors. So, similar to many cases in neurodevelopmental disorders, autism spectrum disorder also doesn't come up with any biomarkers, like there are no test or physical measurements which could help you identify that a particular individual is at the risk or is under the condition of autism spectrum disorder. So most of the diagnosis is based on the behavioral observations, like whether they are having any impairments in social communication, whether they are showing some particular repetitive behaviors or some particular restricted interest, or uh, change in the mode, or change in mood or emotions when there is a change in their routine, the way in which they communicate with people. All these things are some kind of behavioral observations that the experts rely on for the diagnosis. And the key challenge in this is that a lot of subjectivity comes into play, because most of the time the behaviors are not very generalizable. The way in which I behave in a social circumstance is different from someone else behaves. And also children, like my area of focus was mostly on identifying these symptoms in children. And when it comes to children, they are like, they will be showing a very variety of behaviors. They will behave very politely and very obediently at their home. At some circumstances, when they are moving out or a change in environment, they get all hyperactive. They get naughty, all those things. So in between all these things, how we can rightly identify these behaviors, or rightly identify whether there is a behavior which is not very normal to that particular circumstance. All these things are very subjective to the patient, as well as, or subjective to the individual under consideration, as well as for the experts. For example, a expert who is having a 10 years of experience may identify these behaviors very quickly, as well as with very high accuracy. Meanwhile, someone who is very new to the field, they may take more time. And another thing is the autism spectrum disorder is having characteristics which are very similar to some other conditions such as Rett syndrome, ADHD. Most often, autism spectrum disorder as well as ADHD, they are comorbid conditions where both of them can occur simultaneously in a particular individual. So it is very difficult to identify one from the other, and it all depends upon the expertise and experience of the experts as well as the clinicians. So in this scenario, the diagnosis of ASD becomes really challenging, and it leads to a lot of delay in the diagnostic at the right time. And according to the studies, it has been shown that the earlier we diagnose, the earlier we can start the interventions, and the earlier we start the interventions, the greater the chances are of better management of lifestyle. As you may all know, ASD is some condition which cannot be cured, but it could only be managed. So how we can manage this condition to the best possible way? The crucial thing that experts say is to identify it is as early as possible and start the interventions. So we all know the overburdened healthcare system in India and the need for technology support in aiding these healthcare experts and the healthcare systems. The studies have shown that there has been a rapid increase in the prevalence of autism from 2000 since 2020. Excuse me, since 2000 to 2022, and this rise has increased the demand for technology support in addressing the issues of autism, and also finding out some solutions which could aid the system. The point to be noted here is the idea is not to replace the healthcare system or replace the expert from doing the diagnosis, but more than that, what we were trying to do was try to support the healthcare system or support the experts in making a better decisions and trying to cater to many more people with the limited resources that we have. And in between, I would be very happy to take questions in between. If you have any doubts, please feel free to stop me in between and ask. So, coming back to our topic, when we started thinking about the technologies supported solutions for autism spectrum disorder from a diagnostic as well as intervention perspective. We looked into the artificial intelligence scenario, which has been very successful in education, in legislature, in banking and finance, in agriculture, and so on. And moreover, it has been a very good support in healthcare, and coming up to mental health issues also, AI assisted technologies have been a very supportive tool. And that is why we moved on to leverage artificial intelligence based solutions for autism spectrum disorder. And when it comes to autism, as I said, the major areas of interest are the social communication and how to identify the repetitive and restricted behaviors. So when it comes to social engagement, it involves a lot of things like how well we are interacting with our peers, with a group, within a group, how our speech plays a role in the communication, and how our emotional expressions and emotional perceptions are handled during communication, how our gaze works. All these constitute the quality and quantity of the social interaction. And when it comes to the excuse me, when it comes to the social like repetitive behaviors, we look into the stimming behaviors, which are self-stimulatory behaviors. Those who are familiar with the ASD might have seen that the individuals with autism spectrum disorder, they tend to have some specific behaviors or gestures or activities that you can see that they bang their head, they keep on fidgeting, they rock back and forth, they keep on spinning themselves and flickering their hands, and they have specific motor behaviors, etc. And when it comes to Indian context, there have been limited studies which have looked into these kind of behaviors. And what we identified was that identifying these motor behaviors or these gestural or these different events of behaviors will help us uh, aid the experts in figuring out or in objectively identifying the behaviors which can lead to the diagnosis and eventually lead to the interventions. So these are some of the research gaps that we have identified, and eventually these research gaps led to the objectives of our study. Many of the studies in identifying the behaviors for autism were done in global north, for example, the Western countries, US and UK, and many times these solutions couldn't be directly adapted to the Indian context. So we looked at it as a good opportunity how we can use these technologies, or how we in India, whether it will be successful. If not, how we can develop the solutions so that we can identify these behaviors in an Indian context. So, to identify this, we have initially explored how the special educators look into such situations, and how the children of Indian ethnicity, they respond to these kind of interventions. And second thing is a need for multimodal behavioral analysis. So what have been seen is many of the times when it comes to the identification of behaviors for autism diagnosis, many of the work has been focusing on a particular behavior. For example, they will look either into the gaze, or they will look into the streaming behaviors, or they will look into the speech. There has been a lack of holistic view or holistic understanding of all these behaviors together. So there are some diagnostic tools which has been commonly used in India, like implant a diagnostic tool for autism spectrum disorder, as well as the Indian standard for autism assessment ISA tool. All these suggest that it is not an isolated. If it is only in speech, it could be a speech delay. If it is only in fidgeting or some kind of behaviors, it could be only ADHD. But if we look into all these different behaviors like speech as well as gestures and etc, we will see we can make a better diagnosis, whether it is ASD or whether it is ADHD, whether it is Asperger's syndrome, etc. So there is a dire need for a multimodal behavior analysis for comprehensive diagnosis. So in this direction, we started looking for solutions in developing interpretable machine learning for behavioral characteristics and diagnosis, and we looked into facial emotion recognition as well as speech analysis. And finally, we wanted to look into a scenario where once we develop this system, how challenging is to implement it in a real world scenario. And that is where we we did a pilot study in a NGO run school, and tried to see how well the AI assisted system for the diagnosis is accepted by the educators as well as the uh, children there. So the goal is here to develop an AI assisted system supported by machine learning and deep learning technologies to identify the behaviors of multimodal nature, to kind of characterize the behaviors in a child, to help or aid the expert in rightly or objectively assess the child and give a decision on whether the child is under the risk of ASD or not. So as I said, we have initially, I know that the first part of this presentation might feel like a little bored, but I kept it on purpose because none of the project makes sense if there is not much motivation to explore or address the problem at hand. So that is why I purposefully kept this part of the presentation. So as I said, our first idea was to see the acceptance of AI assisted system in an Indian context. When it comes to India, AI is a new concept which is gaining momentum these years. But how we wanted to see how well the system or how well the stakeholders are equipped to accept such a system excuse me, or equipped to use such a system if given an opportunity. So first we wanted to understand the special educators perception towards a assisted autism care. So we try to understand what is the present ecosystem of technology enabled interventions in India, and what according to the special educators could be the benefits and challenges of using a assisted system. And to like many of you might find it interesting that the social robots have been a integral part of autism care in global north or western countries. So we wanted to see how well it could be used in Indian system, how well it will be accepted or it will be looked upon by the stakeholders. So we wanted the AI assisted system to be an embodied agent, and we used a Nao robot. Nao is a humanoid robot from Aldebaran Robotics, and we used Nao robot to interact with the children during the interventions or during the diagnostic task, and how it could use the social robotic capabilities to get most objective and most relevant behaviors from the children from a diagnostic perspective. So we wanted to see how the social robots will be perceived by the stakeholders, and what initiatives could be taken to integrate the social robots into the system. So in this regard, we interviewed 25 special educators who are closely working with the children of autism spectrum disorder, and we used a video presentation and a semi-structured interview and workshops and panel discussions to get the perceptions of these special educators and to understand what they think about using social robots for autism care in India specifically. And our findings were really interesting and motivating to explore further. They identified that there will be challenges. They were worried about the accountability if something happens to the social robots. these are expensive machines, and how they will be able to handle it, what if some damages happen to them, and how they can use the traditional systems along with the social robots. And they were also in a fear whether they will be replaced by the robots or replaced by the AIs eventually, if the AI or social robots are integrated into the system. But at the end of the study, they said that their ultimate goal is in the benefit of the children. If it benefits the child, then they are willing to use it. And they have identified that previous technology supported system has helped the betterment of the children, and they are very positive about using the social robots in autism care. So what we identified and what their suggestions were there, that the social robots or the AI assisted solutions should be cost effective, and there should be some ease of integration. There shouldn't be a vast differences in the nature of their routines during the transition from traditional intervention or diagnostic system to the AI supported systems. And whatever the AI supported systems are being developed, it should be able to cater to the diverse needs of the children. So ASD, as the name suggests, it is a spectrum of disorder. So there is a variance in the way in which the symptoms are presented in each of the children. So this solution should support the varied need of the children, and also it should be culturally appropriate with the Indian context. Excuse me. And there is a dire need of training and support for the stakeholders to implement a assisted system in the traditional system, or to integrate the AI assisted support in the traditional system. So the key takeaway from this study was that despite the challenges, the special educators are very much positive and supportive towards integrating AI assisted solutions for for aiding the experts in care for children with autism. Moving further, we try to understand how the children will respond to a robot assisted or AI assisted system. In this direction, we first identified identified how typically developing or neurotypical children are children who are not diagnosed with autism spectrum disorder. They are considered to be not under the spectrum. So we first did a study where the robots were used to interact with the children using some gamified diagnostic task. These tasks were chosen from the diagnostic procedures, but our aim in this is not in this study was not exactly diagnosing what autism spectrum disorder was, and like how it could be like the AI could be used for diagnosis. Our objective in this study was just to see how the children responded to such an interaction with the robot or with the AI assisted system. So this was just a preliminary study to see the responsiveness of the children. So the participants were from the age group of 3 to 6, and we used a Cosmo robot, which is a toy-like robot, and we introduced the robots to the children, and there are two tasks which we gamified. One is the response to name task, where the robot will call the child's name, and the child is supposed to respond to the name call. And second one is joint attention task, where the children is supposed to play with the robot, and the robot there are three different cubes as given in this particular pictorial representation, and one of the cube will light up, and the robot will say the color in which the cube lights up, and the child has to look at the correct look and tap at the correct cube. So that was the task which was given, which is trying to see whether the child could share attention along with the robot and respond to the instructions or directions given by the robot. These tasks are standard tasks given in the diagnostic criteria. We choose this just to see how well the robot could administer the task and the capability of the robot in administering the task, and also to see the responsiveness of the child in this particular session. And we also used a questionnaire to understand the parent perception. So the experiment showed that all the children could score very high. So when it comes to the table number one, the scores are given 0, 1, and 2. So the higher the performance, the less the score is, and the lower the score, the less chance that the child will be under the spectrum or not. And we could see that the all the children could actively respond to the directions given by the robot and could respond with eye contact to the robot. And overall, there was a positive response to both, towards robot-assisted interactions. So this phase of our study gave enough motivation and enough evidence that the stakeholders are very positive. So major scale stakeholders in the neurodevelopmental disorder, especially in autism spectrum disorder, is the individuals under assessment, which are the children here, and the parents who are the caregivers of the children, and the third major stakeholder is the special educators. So the first phase of our study was to understand the stakeholders' perception. So we have covered the special educators, the parents, as well as the children's responsiveness. Excuse me. And after this study, it gave us enough motivation to look into development of AI assisted or machine learning and deep learning technologies to find out the behaviors and develop a system that would enable us to identify the behaviors for diagnosis. Now we will move on to a more technical part of this presentation. So how to model the behaviors for the diagnosis. I'll take a brief pause here. If anyone have any queries, you can ask me. Okay, so I believe that is a green signal to go ahead. So as I told earlier, first we looked into the facial expression recognition in scarce data setting. So when we looked into the facial expression recognition, the highest challenge was acquiring the data sets. There were not many data sets which gave facial expression data. Of course, there are some data sets which are the FER data set, which are of uh, which are of different ethnicity, and we wanted to focus more on Indian ethnic data set. And when it comes to autism data set or children data set, like since we were looking mostly into the child behaviors, there are not many data sets that had uh, child facial expressions. And excuse me. There are some data sets which are of smaller sizes, but you all know when it comes to deep learning techniques, most of the time we need a large data set to train the models. Now we were stuck at that point, and what could be done? One is the data scarcity. Like the major challenges that we face were data scarcity, and data collection and annotation is not possible because we are talking about facial expression data which reveals the identity, and if we collect the data, there are issues of privacy and data security, and there is a huge challenge in annotating the data as well. So we then realized that we could use the transfer learning approaches to handle this challenge. And there are some, like as I said, there are some data sets which are smaller in size but have child facial expression data. Then our idea was to use was to think how to use this smaller data sets and leverage the understanding of, or leverage the knowledge captured in the from the smaller data set to to transfer this knowledge to a new domain, which is our like Indian ethnic child facial expression data. So that is where we came up with the multi-source domain adaptation technique, and we looked into the source-free multi-source transfer learning technique, mainly because many of the times the idea is we will have some inferences or some models which are trained on these smaller data sets, but due to privacy and security reasons we may not be having access to these source data sets. So we wanted to see how we can leverage the information or leverage the knowledge gained from these smaller data sets, where we don't have access to this data set but we have access to the models which are trained on these data sets. So the model captures the knowledge of the patterns or the inferences from these data sets, and we have access to these models or those inferences, but not access to the data sets. That is where the source free multi-source transfer learning came into action. So the hypothesis is, as I have mentioned, knowledge gained from multiple data sources of similar domains could be leveraged to inform a model on a related task on a target data set. So in this way, the knowledge or the inferences on the target data sets could data set could be made more generalizable and can perform better on a new domain. So we proposed a multivariate maximum correlation method, which builds on the ensemble of pre-trained source networks to represent a target classifier. So before going on to the details, I will just briefly introduce what is maximum correlation. So given two jointly distributed random variables x and y, which are element of the the space, with positive variance and maximal correlation of xy, with positive variance, the maximum correlation is defined as the supremum or argmax of expectation of any transformation on this values x and y. So f of x is any kind of transformations on this variable x, and g of y is any possible transformation of y, like transformation on the variable y. So maximum correlation gives a quantitative measure of how well these two variables x and y are associated with each other. So it gives a strength of association between x and y, or any transformation of x and y. So this is the proposed model that that has helped us here. So we have some target samples. So as I said, we are not having access on the source data, but we have access to the models which have been trained on this source data. Okay, and you should also remember that these we have no control over the control over the models which have been trained on the source data. That is why we have put locks on these models in that blue. Okay, that is why we have put these locks on these models, blue, red, and green. So that is an important point here. We don't have access to the source data. We don't have control over the training process of the pre-trained networks. We just can get some inferences from the pre-trained models. So any deep learning model could be considered as two different components. One is the feature extraction component, which is given here, and second one is the fully connected layer, which could be considered as the mapping from the features to the corresponding classes. So that is the second part. So any deep learning model could be considered as two different transformation or two different functions. One is the feature mapping function, and second one is the classification function. Okay. Excuse me. So what we are doing here is we give the target samples, we extract the features using the pre-trained network on these target samples. We don't want the inferences here because it is on the source classification. It is done on the source classification. So we don't need the second part. So we take the features from each one of these pre-trained networks. So we get all this, and now the idea is using the maximal correlation, we have to find out the hypothesis function or the classification function in such a way that the maximum correlation, the aggregate maximal correlation of all these ensemble network is maximized. So that was our, so like for example, source uh, source network 1 may have some kind of inferences on this data. Source network 2 might have another set of inferences for this same data, and source network n might have another set of inferences for the same data. What we are trying to do is we are trying to accumulate the knowledge or inferences that these networks have inferred from this particular data, and making use of these inferences together to get the best possible hypothesis function or best possible classification on our target sample. So an analogy could be, so you are going to a particular place, you or particular city on a trip. So you will ask your friend, one of your friend who has already been there, about that. Say you are going to Goa, so you ask that particular friend, what was your experience. So he will give you some experience about the stay there, some experience about the food there, etc. And there is another friend of yours who has who also have visited Goa. So you will ask that particular friend what was his experience. He may not give an information of the stay, but he may talk about the beaches, where which beach to visit, which part of North Goa or South Goa, which part of the Goa he found better for a visit, etc. So you got some information from friend A and some other information from friend B, but both are relevant, but both are not common. So what we are trying here, uh, what you will try is to assimilate all this information from different friends, and you try to use all this information while you are going to visit that place. Similarly, here we are trying to see from the given target samples. Source 1 will find some particular set of information, source 2 will give some particular set of inferences, and source n will get some particular set of information, and the entire setup will try to find the corresponding mapping to the target classification in such a way that it will assimilate the information from all these different source networks. Excuse me. So the problem statement is we are using this as a multi-source domain adaptation problem, where there are n labeled source domains and one target domain, uh, and the input space be X, and the classification is among M categories. So we have M classes here. And there are pre-trained source models, which are that blue, green, and the red source networks that we have seen. There could be n different source models, where the jth model represent a mapping from the input space to the M class. And the target data set is represented as dt, xi of t, and yi of t. Xi are the features, and yi is the corresponding sample label. And the problem is, another problem here is that we have only few samples, and the approach is to try to understand or learn a classifier using an ensemble of pre-trained source classifiers without access to the source data set. And also remember that we don't have access to the or control over the training of the source data, source classifiers. So the data points or sample points here are facial expression images represented by an MPN matrix. So each pre-trained source networks, as I have explained before, is a mapping, could be considered as two different functions. One part is the mapping from input vector to the feature vector, and second part is the mapping from the feature vector to the output label. So there are two functions in action. And how can we use the maximal correlation here? The maximal correlation is rho, which shows the strength of the association between between both. So argmax of expectation of fx and gy. So here ffx is the feature mapping which we have extracted from the pre-trained networks, and gfy is the hypothesis function or the classification function, which here we are trying to figure out using the maximal correlation. So we will find out all possible associations or all possible transformations of y in such a way that rho is maximized over the entire ensemble. So the maximal correlation function g of y will be expectation of f of x, and rho of f of g will be expectation of f of x into g of x for each source. So using the maximal correlation function, we will figure out g of y, that is the hypothesis function, and for each one of these source networks over the target samples. And once these source networks or source hypothesis function for each one of the source network is identified, then the training is completed. So during the training phase, we will figure out the hypothesis function for each source network in such a way that the aggregate maximal correlation is maximized. And once this training phase is complete, the predictive phase is simple. It is just the argmax of p of y given x, which could be just finding out these functions f of x in g of x and rho of z. I'll go back a little bit and show you how it works. Once this g of y has been identified, the prediction will be given a sample. It will be finding out f of s into g of x and rho of source 1, where rho of source 1 acts as a weightage for this particular source, how much contribution this particular source network is giving towards the inference. So this will act as a weight to source 1. Rho s2 will act as a weight for source 2. So this is a very straightforward approach where we can use multiple source networks to find out inference on the target data set. And we have run it on different facial emotion data sets like RAFDB, FER, CAFE, and JAFE data sets. These are facial expression recognition data sets. And our approach has worked well in most of the settings, as you can see in the response. I wouldn't go into the details of the results considering the time constraint, but we have used ResNet and LeNet networks as the backbone networks for our pre-trained source network. So we have found out that this particular approach works with a very few samples. So you can see that this is an elbow curve where at 20 samples, the particular approach has given really good accuracies. And we have also seen that when it comes to a particular sample point, if we remove the data set under consideration, which is contributing more, which is indicated by the rho, if we remove that particular source network, then the overall accuracy falls down to a great extent. That means the rho is rightly capturing the contribution of each of the source network. Now, what is the major advantage of using such a particular approach? Most of the cases, the deep learning networks are black box. We don't know how it is working and like why it is working, and we don't know much about interpreting the responses. That is why this where multi-source transfer learning approach using maximal correlation helps a lot, since it is a diagnostic perspective and a healthcare scenario. We always need to interpret the data, or we need to explain the responses or the decisions to a great extent. That is where our approaches stand out. Here we can explain the results, that which particular data set is, or which particular source data is contributing more, and how much it is contributing, and why it is performing better. So the MSTL approach could translate the knowledge learned from multiple source tasks to target task, and it has been validated using benchmark data sets, and it could also show that we can interpret the data set with the help of the maximal correlation analysis. Vikas sir, do I have time or hello?
Yes, ma'am.
Yeah, do
You
I
can.
have a
Yes,
time?
ma'am.
Otherwise, I'll wind up.
Yes, ma'am. It is till 1:30, but you may extend to 5 to 10 minutes.
Okay, sure, thank
Okay.
you. So I'll briefly go through the next work that we have explored, that is figuring out the acoustic and linguistic behaviors of autism identification. So mostly the work has been done in lexical and syntactic scenarios, and when it comes to autism, we also identified that semantic and pragmatics, that what is the speech meaning under a particular context. That is also really important when analyzing the behaviors of the speech in autism. So that is why we looked into the semantics and pragmatics also. And I will briefly go through, like skip these slides and briefly go through what we have identified. So in this direction, we have identified different features like maximum length of utterances the child gives, and the number of distinct word roots spoken by the children, how much is the initiative of the children, how much the child repeats when asked a question, what is the repetitive ratio, repetitive content with respect to the child, and with respect to with respect to the conversation they are having with a caregiver or a expert. So these are some of the things that we have identified. Mostly we did it using the BERT and the NLP techniques to identify the speech behaviors which are of interest in autism diagnosis. And this is a brief architecture of what we have done. The child and partner, the partner could be a speech therapist or a special educator or a caregiver. And these speech signals were transcribed, and we used both the textual as well as the um, acoustic data, and tried to acoustic data, and try to identify how much is the contribution of semantic and pragmatic features played. And we identified that the semantic and pragmatic features, such as the non-distinct word roots, unexpected words spoken by the child. For example, these children may talk beyond the context or out of context sometimes. So these features or behaviors are captured by unexpected words. So we identified that semantic and pragmatic speech features also contributed towards the diagnosis, and it should be addressed. And when it comes to semantic, when we realize that semantic and pragmatic features are important, we try to explore what could be the semantic and pragmatic features in Hindi, particularly, which has to be considered while diagnosis. And we set up a scenario where the child had to go through some activities with the experts, where the child can interact. And during these activities, we collected the speech data, and we extracted the audio and the transcript textual data, and analyzed it. The different acoustic data which were considered were using the extended GMAP features, and lexical, semantic, and syntactic features were also considered. And The overall response was that the linguistic and the acoustic features together provided around more than 90% F1 score in identifying the or distinguishing the children under ASD and typically developing or neurotypical children. Also, we wanted to identify or we wanted to do an interpretability analysis using SHAP to see which of these features contributed more and whether it is making any sense with respect to the diagnostic tool. So there we used SHAP analysis or and we identified that features like unintelligent propagation, that some jargons, use of jargons, then short utterances, then POS tags like add positions, uh, etc. Add positions are something like where we use beta, beti. It shows for example, if it is in Hindi, we usually use mm, uh, mera beta and meri beti, something like that. These kinds of things are not happening in English. So in these kind of situations we have to have context specific uh, systems or context specific algorithms to identify these behaviors. And these behaviors played a important role in or these particular behaviors played an important role in distinguishing the children with autism and neurotypical children. So these variations in performance have been attributed to the different grammatical structures and linguistic characteristics in Hindi and English, which we identify without much effort. But when it comes to algorithms, we have to teach the algorithms, and this also shows that out of the shelf solutions for speech based analysis couldn't be used in different contexts, couldn't be used in all the contexts or in case of Hindi. So we need tailor made solutions. So the key takeaway is that there are differences in manifestation. Also, the behaviors also change. The behavior in which or the way in which the particular behavior is presented in children who is of Indian ethnicity is different from the one who is speaking English. In English, different set of features are to be looked into. In Hindi, different set of features are to be looked into. We cannot generalize the features also. We cannot generalize the behaviors as well. Finally, we validated the system using a brief pilot study in a NGO run school where we conducted the robot assisted or robot mediated intervention or mediated diagnostic procedure with the children. There were 21 participants. We used the different diagnostic tasks like conversation, response to joint attention, etc. And the child used to interact with the robot assistant as well as the human administrator. And we extracted the video. Then from the video, the speech and the facial expression were extracted. And finally, along with the diagnostic suggestion, we also gave a report which showed that uh, how much behaviors were indicative towards the diagnosis. So we gave a report which shows that how many times the unintelligent words were uttered, how many events of echolalia was uttered. That is a particular condition in autism spectrum disorder. How long the child responded happily, how long the child responded anxiously, etc. So this report is kind of like an X-ray to a orthopedic surgeon. The experts or special educators or neurologists could use this report to counter verify their assessment and give a more informed decision on the assessment. Our study gave a positive evidence towards the AI-enabled diagnostic system or decision support system. Rather than a diagnosis system, it would be a decision support system based on which the experts could make a objective diagnosis or objective assessment. So here the overall contribution or highlight is that we could effectively use AI and machine learning as well as deep learning technologies to solve a real world problem, to support the existing system by helping them or aiding them make better observations. I hope that gives you better motivation to work towards your goal and bring some change in the real world, bring some change in the society that you are in. So these are some of our collaborators. Thank you, and if you have any questions, feel free to ask me now.
So thank you so much, ma'am. I request all the participants, if you have some query, just you can put it in the chat box. So one query is there, ma'am. Which speech feature are used in this model?
Yeah, okay. So I have used both acoustic as well as linguistic features. Acoustic features are mostly on the speech signals, and for these we have used the extended GMAP features, which is a standard set of features used for speech analysis. If you can reach out to me, I can share the papers or relevant references for that. And for linguistic features, like we have used syntactic, semantic. I am going back to that particular slide. Sorry, I skipped it in a hurry because of the interest of time. Yeah. Yeah, so these are the linguistic features that we have used. So n-grams were used as the baseline features. So lexical features were the non-distinct word roots, POS tags and its frequencies, the mean length of utterances, that is the uh, length of utterance means one particular conversation unit, and syntactic features like unintelligent propagation, then syntactic complexity, how wide and how varied the syntax or the varied the words are used, and the use of unexpected words. And semantic and pragmatic features were extracted from the diagnostic tools used in India. That is what I am saying. ISA tool, that is Indian Standard for Assessment of Autism, and INCLA tool, INDT-ASD. So there are some features that are, or speech events that are mentioned in that particular tool, which are like initiative to ask questions, how many times the child repeats its own utterances as well as the utterances from the conversation partner, and how well the how meaningful the child speech is, or with respect to the context. They have a tendency to go out of context many a times during the conversation. That is represented by the child to child discourse coherence. That is how well each sentence is spoken by the child is coherent to each other. And child partner discourse coherence, where whether the child is making conversation which is relevant to the particular context, which is relevant to the conversation that the expert made. And echolalia is something where the child repeats whatever the conversation partner says, and use of metaphors or jargons. So these are some of the features, linguistic features that we have used. So I hope I have answered your question.
So any more question? If not, then we may wind up the session. Okay, so no more query, ma'am.
Yeah, thank you all. Thank you for
I would
having
like
me.
I would like to thank you, madam, for agreeing at the last minutes. Thank you so much,
It was
ma'am,
a pleasure.
and I hope participants who are working in this field have definitely got benefited from this particular session. So thank you so much from the ENICT team. Thank you so much, ma'am.
Yeah, thank you.
Okay.
Thank you all.
So participants, the next session will be starting from 5. So we will join back at 5 only. So thank